Hello friends, I am Vivek Kumar, Assistant Professor, Department of Electronics, Faculty Engineering, Gurukul Kangadi Vishwavidyalaya, Haridwar. So in this lecture, we are going to discuss control sources. So there are various control sources. So we'll discuss one by one. So first one is voltage control voltage source. That is, the output voltage will depend on input voltage. So the circuit diagram is shown here, and the schematic diagram is shown here. So this is a schematic diagram of the voltage control voltage source. So in this case, the output voltage V0 is proportional to Vi, that is Vi, this for input voltage. So this is voltage source K times V1 when K is some constant. V output is equal to K times V1. So using operation amplifier, we can also design this kind of sources. That is, using operation amplifier, we can also design voltage controlled voltage source. So for this circuit is shown here. So this is the circuit of voltage controlled voltage source. So in this case, V0 can be written as minus Rf by R1 into Vi. This is simply inverting configuration, and we can write directly from formula, that is V0 is equal to minus Rf by R1 into Vi. So treating minus Rf by R1 as K, we can say that output V0 is depending on V input, that is output V0 is equal to K times Vi, where K is equal to minus Rf upon R1. So this is the voltage controlled voltage source. Next is voltage controlled current source, that is output current is depending on input voltage. So this is voltage controlled current source. So output will be current and input will be voltage. So the diagram is shown here. So this output current I0 is given as K times V1. So I0 is depending on V1, this V1. So I0 is equal to K V1, where K is some constant. I0 is equal to K times V input. So we can also design voltage controlled current source using operation amplifier. So this is the circuit diagram of VCCS. In this case, output current I0, that is current through resistance RL, this can be calculated. And due to virtual ground concept, we can write it as, we can say that potential of non-inverting terminal is equal to potential of inverting terminal. This is equal to 0 because this potential is 0. So we can apply nodal analysis here. We can write V1 minus 0 upon R1 is equal to 0 minus V0 upon RL. This is equal to I0. So this I0 can be written as V1 by R1. So treating 1 upon R1 equal to K, we can write I0 is equal to K times V1. So in this case, the output current I0 is depending on input voltage Vi. So this is voltage current controlled current source. Now third one, current controlled voltage source. So output voltage will be controlled by input current. So this is input current I1 and this is output voltage V0. So this output voltage V0 can be written as K times I1, that is some constant, proportionality constant, into I1, that is this current I1, input current. So using operation amplifier, we can also design this. So at input side or input of the inverting terminal, this is some current source I1. This is output current I0 and this is output voltage V0. So we can write, because essentially current inside the operation amplifier is 0, because this potential of inverting terminal and potential of non-inverting terminal is 0. So we can write this current II, that is input current, is equal to this current. And this current can be written as 0 volt minus V naught upon this RL. Now this V naught can be written simply I1 into RL. So this is current controlled voltage source. Next one is current controlled current source. So output is also current, input is also current. So output can be written, this output I naught can be written as K times input, that is K times this I1. So this can be written as K times I1. So output I naught is equal to K times input current, that is I1. So using operation amplifier we can also design this. So this is the circuit of current controlled current source. This is input current source I1. So this current is dividing into two parts, that is this current is dividing into two parts. One is this and second one is this. So we can write the output current, this output current I naught, this is equal to I1 plus I2, I1 plus I2. That is this current is equal to this current plus this current. So this is current source, this is I1 plus I1 into R1 divided by R2. This plus is in fact, sorry friends, this is division. So treat this plus sign as division. Okay, treat this plus sign as division sign. So we can write I1 common, so 1 plus R1 plus R2 into I1. So I naught is equal to 1 plus I naught is equal to 1 plus R1 upon R2 into I1. So output current I naught is equal to K times I1, where K is equal to 1 plus R1 upon R2. So this is current controlled current source. Now based on this we can take one example here. So this is circuit diagram. We have to prove that this is a voltage controlled current source where IL, that is this load current IL is independent of RL. So we have to prove that this is a voltage controlled current source. Voltage controlled current source means output is current and input will be some voltage source. So now we can apply node analysis here, and from virtual ground concept we know that this potential is equal to this potential. So potential of this point, that is inverting terminal, is equal to 0 volt, because this potential is 0 volt. Now we can apply node analysis here. So V1 minus 0 volt upon R, that is this resistor, is equal to I1, and this is equal to IF, that is this current, and this can be written as 0 minus V naught upon this resistor, that is 100R. So this is the relation we found. V1 upon R is equal to minus V naught upon 100R. Now this IL can be calculated, and IL can be written as this IF minus this I naught. So IL is equal to this IF minus I naught. Simple. Now this IL can be equal to IF minus I naught, equal to V1 upon R minus of minus I naught, that is I naught was equal to V naught upon R, equal to minus 100 times V1 upon R. So this is written here, minus 100 V1 upon R. So this is equal to IL. So IL is equal to 101 V1 upon R, and this is independent of RL. So we can say that output current is independent of output load, so output will be a current source. So this proves that this circuit is a some current source and it is dependent on some voltage. So this is voltage. So this is called voltage controlled current source. So output is current, input is voltage. So this was a simple example, friends. Thank you. Thanks for watching.